quick video to explain how to solve oblique triangles. In this section, remember that we are learning new methods to solve oblique triangles since they are non-right triangles and we cannot always use sine and cosine. So I want you to, this is more of a summary, so review law of cosines and law of sines and the area formulas mentioned in these sections we've been discussing. And I just want to summarize in this video our decision tree for solving triangles. So first of all, think about whether your triangle has a right angle or not. If it does, these are triangles we solved in the beginning of the semester. You can use sine, cosine, tangent, they're reciprocal functions, or you might need to use their inverses if you have information about the sides but not angles. You can use the inverse function. Remember, the inverse sine is an angle, inverse cosine is an angle, arc tangent or the inverse of tangent is an angle. So that will help you solve for that information. These are triangles, or in these cases you could do this in the beginning of the semester. What we're working on now are oblique triangles. So does your triangle have a right angle? No, it is an oblique triangle. Well, what information were you given? If you have a side angle side, meaning when you draw the triangle and you go around that triangle either clockwise or counterclockwise, you are given a side and then two angles. So in the triangle, those 8 angles would be on the same, they would be connected by a side. So side angle angle or angle side angle. In an angle side angle, that's where you have 2 angles in the side that connects them. So in these two cases, simply use law of sines. Now you might set your formula a little bit different with the ratios depending on what you're looking for, but still law of sines will be fairly straightforward. If you have a side-side angle case, this is possibly the ambiguous case. You may have no issues with this, but we'll come back and talk about this. This could lead to 3 other cases. Now, if you were given a side angle side, so 2 sides and an angle between, or all 3 sides, then you will use law of cosines. When you have a side, 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 try to solve for the largest angle first. Side angle side rarely gives you any difficulty, but occasionally if you have a difficult problem, consider that the smallest angle lies across from the smallest side, the biggest angle lies across from the biggest side, and by reasoning out your work you can usually solve that without any difficulty. Back to the side-side angle. So in class I called this the donkey case. This is the stubborn case and it might lead to some issues. So in this case, the ambiguous case, be sure to check for possible angles on the interval 90 degrees to 180 degrees. So what I mean by that, if you use, when you use law of sines, you will end up having to use inverse sine, so arc sine. When you do that, remember that the inverse of sine is not, the range is not defined in the second quadrant from 90 degrees to 180, but there still could be values there that give you the same, so that there still could be angles in the second quadrant where sine evaluated at those would give you the same value. And so that means if your triangle has room for an angle that's between 90 and 180, then you might need to check the second quadrant for your answer. Now often, and in some cases, your only solution is actually in the second quadrant. So if you get an answer and that angle is far too small to be across from such a big side, then your answer probably lies in quadrant 2, so you need to check that. So here are some outcomes that can happen. When you're using law of sines and you use inverse sine and your calculator gives you a domain error, I need you to pause and think about why that would be. There might be situations where you are given problems and there is no triangle possible. In such a case, I want you to defend your work. Think about the fact that the smallest angle must be across from the smallest side, the biggest angle must be across from the biggest side. Often you can even catch those before you put in this much time. Another outcome is that you could have 2 possible angles. So when you use arc sine, suppose that you plug in your calculator arc sine of a value and you get in your calculator 40 degrees. Alright, now that's an angle. Sine of 40 degrees has such and such value, but isn't there another angle in quadrant 2 where sine evaluated at perhaps 140 would have the exact same value as sine of 40? So how do you know which one to solve for? Well, you don't. If you had a side, 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 you were not supplied with enough information, so you're responsible for solving for both triangles. I talk about an architect. If they were given that information, well, the client didn't give them enough information. You don't want to accuse the client of being wrong right away, so you just simply build the blue plans for both, and then you make the client happy and show them you have both results. So be sure to solve for both triangles. Lastly, you may have no issues. You could have a sine side angle and still have absolutely no issues. That is quite common that is quite common as well. So when you're solving, if you can't get an angle in quadrant 2, then you have no issue. No domain errors, you probably have no issue, and so there will just be one triangle, and simply solve that one triangle. So this is really all it comes down to for solving triangles. In these two sections, we also discussed area. So in geometry, you learned that area was 1/2 base times height for any right triangle. That is still the same. That formula will work. If you don't have that information, or if you don't have the height directly, then learning about law of sines and law of cosines introduces 2 new formulas, which lead to new area formulas. So if your triangle does not have a right angle, then it is an oblique triangle. If you have enough information such as an SAS, so a side angle side triangle, then you'll use 1/2, and this is really base times height. If you'll recall, when we were building law of sines, this similar expression came about where height was equal to b sine of c if you were given a triangle such as this, so side angle side. So these formulas really are the same as 1/2 base times height, and they can be used for area. Often you might not have an SAS, but you may be able to do one quick step and form an SAS so that you could also use these formulas as well. Remember, try not to round on top of rounding, so be careful with that, but these formulas will frequently work. If you were given an SSS, so side, 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 you weren't given any angles, then Heron's formula is a pretty neat formula, and it's quite useful. So we let S denote the semi-perimeter, so it's half of your perimeter of the triangle, and the area will be the square root of this product. If you haven't seen that proven, that's a pretty neat proof to work out yourself, but Heron's formula is kind of a cool trick if you have all 3 sides of a triangle. If you have the vertices, 3 points of a triangle in space or in a plane, then the cross product is helpful. So the cross product, when you form vectors with 2 of the sides of the triangle, you can take the cross product and you'll take 1/2 of the absolute value of the cross product. And those are useful methods for finding the area of a triangle. So these 2 decision trees were just really to summarize what we have discussed in trig recently. Thank you.